Next example, evaluate integration 1 to 4, 0 to 2, 6x square y minus 2x dy dx. So this 0 to 2 is limit on y because dy is first here, and 1 to 4 is limit on x. So integrating with respect to y first here. So its integration is 6x square is constant, and integration of y square is y square by 3. 6 by 3 becomes 3. And then 2x is now constant with respect to y. So its integration is 2x into y. Value at the lower limit, value at the upper limit. That is substitute y as 2, we have this answer. And y as 0, we have answer 0. And then its integration with respect to x is what? 12x cubed by 3. 12 by 3 is 4. Then 4x square by 2. And therefore we have this value at the upper limit, value at the lower limit. That is value at 4 is 2 to 4. And value at 1 is 2. The answer is 2 to 2. Next problem is integration 0 to 1, 1 to 2. This dy dx, that is 1 to 2 is limit on y and 0 to 1 is limit on x. So integration with respect to y is this. Then value at the upper limit, value at the lower limit, value at the upper limit, value at the lower limit. And then its simplification is this, and its integration with respect to x is this. And from 0 to 1. So answer is minus 6. Same problem, minus 3 to 3, 0 to pi. This dx dy. So 0 to pi is the limit on x because dx is first, and minus 3 to 3 is limit on y. So integration with respect to y, x first, then y is constant, and so its integration is y into x. Here is y square is constant. Integration of cos x is sin x. 0 to pi by 2. So value at the upper limit, value at the lower limit. So we have this, and then its integration with respect to y is what? Y square by 2. Here y cube by 3 minus 3 to 3. Answer is 18. Then 1 to 3, 1 to 5, ln y by log y by x into y dy dx. That is 1 to 5 is the limit on y, and 1 to 3 is limit on x. So either integrate with respect to y first or x first. So here is the integration with respect to y first. So 1 by x is constant, and log y by y with respect to y integration, log y by y integration with respect to y is log y square by 2, because the derivative of log y square is what? 2 log y into derivative of log y is 1 by y. 2 get cancelled. So we have this log y by y integration is log y square by 2, 1 to 5, because log y bracket square, its integration is 2 log y into 1 by y. That is, we have log y by y answer. So, and the value at the upper limit, that is substitute y is 5 and then y is 1, log 1 is 0. So we have this, and then its integration is with respect to x. X is what? 1 by x integration log x, and then value at the upper limit, 1 minus value at the lower limit. That is substitute 3, and then substitute x as 1, log y, log 1 is 0. So yeah, this answer. We also integrate this with respect to x first, then interchange this, write integration 1 to 5, then 1 to 3, and then write dx dy. Because limits are constants, and therefore we interchange the limits, order of the limit. Then here, instead of x and y, the notations are u and v. So integration 0 to 1, integration 0 to 1 v. So integrate first with respect to u or first with respect to v. With respect to u integration, so we have this u plus v square. V square is now constant. V is constant, v as it is, and v square is constant, and so its integration is raised to 5 divided by 5 into derivative of u is 1 divided by coefficient of u is 1. So 0 to 1, and then a value at the upper limit minus value at the lower limit, and then integration with respect to v. So in order to integrate with respect to v, so this is the substitute of 1 plus v square as t, 1 plus v square as t, and then 2v dv is dt, and therefore its integration is t raised to 6 by 6, then 10 into 6 is 100, then substitute t as 1 plus v square from 0 to 1. This is v raised to 12 by 12, 12 into 5 is 60. Value at the upper limit, that is there, this is the separate integration, separate finally this integration by substituting 1 plus v square as t. and then integration of this quantity, this function e raised to x plus 3y. 0 to 3 is limit on x and 0 to 1 is limit on y. So e raised to x plus 3y is integration is e raised to x plus 3y. 3y is now constant. So integration of e raised to x is e raised to x, and e raised to ax plus b is what? E raised to ax plus b divided by a. Like that, a is 1, a is 1, x plus b is 3y. So we have this, and then its integration upper limit lower limit value, and then integration with respect to y is again divided by 3, e raised to 3y plus 3, e raised to x plus b, e raised to x plus b divided by a. Similarly here rule, and then we have this answer. The integration 0 to 1, integration 0 to 3, this d by dx. There is g integration 0 to 3 is integration on with respect to y. 0 to 3 is limit on y, 0 to x is limit on x. So integrate with respect to y first or with respect to x first. So if we integrate with respect to y first, then x is constant, and we substitute x square plus y square as a t, and then its derivative is with respect to y. X square derivative is 0, 2y dy is dt, 2y dy dt, 2y dy is dt, 1 half by. So write that 1 half. Adjustment is what? Multiply by 2, divide by 2, and then substitute that, and then find integration. We have this answer from 0 to 1. Value at the upper limit minus value at the lower limit, and then integration with respect to x. This answer is this. Similarly, 0 to 2, 0 to pi, r sine square theta d theta dr. So that is the limit on theta is 0 to pi, and limit on r is 0 to 2. So integrating with respect to first theta, then we have to integrate sine square theta. Sine square theta, we substitute its value 1 minus cos 2 theta divided by 2, value of sine square theta. And then integration of 1 is theta, integration of cos 2 theta is sine 2 theta divided by 2, 0 to pi. So, and value at the upper limit minus value at the lower limit, and then integration with respect to r. So r square by 4 pi, and pi is the answer. So here is the s and t are notation instead of x and y. So integration 0 to 1. So integrate with respect to s first, then we have this raised to half, s plus t raised to half, half plus 1 is 3 by 2 divided by 3 by 2. And then its value at upper limit minus value at the lower limit, and then its integration with respect to t is this, and then value at the upper limit minus value at the lower limit. Evaluate double integral over r sine x minus y dA, where r is this. So limit of x are 0 to pi, pi by 2, and limit of y 0 to pi by 2. So this integration is equal to 0 to pi by 2, 0 to pi by 2 sine x minus y dy dx or dx dy, right? Dy dx or dx dy. Then sine x minus y, x is now constant, y is variable, its coefficient is minus 1, so its integration is minus cos x minus y, integration of sine x minus y divided by minus 1, coefficient of y is minus 1, and then value at the upper limit minus value at the lower limit, that is substitute x, y as pi by 2 and y as 0. So we have this, and then its integration cos integration is sine, okay, and here is also sine, then upper limit lower limit, answer is 0. Evaluate double integral over r r is this, that is the double integration over r of this is equal to integration 0 to 2, integration 1 to 2, y plus x into y minus y raised to minus 2 dy dx, because this 1 to 2 is limit on y, so write first dy, then dx, then integration with respect to y is this, and then value at the upper limit minus value at the lower limit, and its simplification, and then integration with respect to x is this, from 0 to 2, value answer is 4. Evaluate double integration over r is 0 to 1, x runs from 0 to 1, y runs from minus 3 to 3, 0 to 1. Write dx first now, because if you write the 0 to 1 in second place, then write dx as first place, that is 0 to 1 is limit on x. Then integration with respect to x first. So y square is constant, and 2x by x square plus 1, that is f dash x divided by fx rule, is log fx. X square plus 1 derivative is 2x, so f dash x divided by fx log x square plus 1 is the integration. then value at the upper limit minus value at the lower limit, and then integration with respect to y is y cube by 3, and then upper limit value at upper limit, value at lower limit. We have this answer 9 log 2. Integration, double integration x sin x plus y dA. R is this, that is x runs from 0 to pi by 6, y runs from 0 to pi by 3. 0 to pi by 6, 0 to pi by 3, x sin x plus y dy dx. 0 to pi by 3 is limit on y, so write dy first. And then integration with respect to y, x is constant, sin x plus y. Integration is minus cos x plus y divided by 1, 0 to pi by 3, value at the upper limit minus value at the lower limit. And then integration with respect to x is this, x into this. This is part rule, that is x, and this first integration of second minus integration of second derivative of first. We have this answer, and then upper limit lower limit value, and integration of this quantity is this. So we have this answer minus root 3 minus 1 divided by 2 minus pi by 12. Double integration over r, x divided by 1 plus x into y dA. R is what? 0 to 1, 0 to 1. That is x limit of x is 0 to 1, y is limit of y 0 to 1. And then integrate with respect to y first, or with integrate with respect to x first. So integration with respect to y first is simple. So x dy 1 plus x into y, log 1 plus x into y divided by x, because integration of 1 by ax plus b is log ax plus b divided by a. So here a is x, ax plus b is 1, so x is constant, so log ax plus b divided by a. Now a is x from 0 to 1, then value at upper limit minus value at lower limit, and then log 1 plus x, right? Log 1 plus x into 1, and then write log 1 plus x as first and 1 as second. So first integration of second 1 minus integration of second derivative of first dx, and then we have this answer. And log integration of 0 to 1, 1 by 1 plus x is what? Into x, so write this into x, 1 plus x minus 1, and then 1 by 1 plus x divided by 1 plus x is 1, and 1 minus 1 by 1 plus x, and then integration of 1 is x, and integration of 1 by 1 plus x is log 1 plus x, value at the upper limit minus value at the lower limit. Find the volume of the solid lies under the plane 4x plus 6y minus 2z plus 15 is equal to 0, and above the rectangle are xy, x runs from minus 1 to 2, y runs from minus 1 to 1. So double integration volume of the solid, double integration over r z dA. This is the formula. So write z as this value of z from this is this dy dx, and y runs from and x runs from, y runs from minus 1 to 1, x runs from 1 to 2, minus 1 to 2. So find the value of z and write here z dA. Okay, and then answer is this 51. Find the volume of the solid enclosed by surface z is equal to, so the value of z is given. Again formula is what? Double integration volume is double integration over r z dA. So z is this x square y dx dy, and x runs from 0 to 2 and y runs from 0 to pi by 4. So write dx first, then dy, and then integration with respect to x square y is constant, x integration of x is x square by 2, upper limit lower limit, and then it's x square y is its integration is tan y, because tan y derivative of tan y is x square y. So we have the answer 2, tan pi by 4 is 1. Then evaluate integral double integral over r this dA, where r is this. So integration, the given integration is equal to minus 1 to 1, x runs from, y runs from 0 to 1. Then integrate with respect to y first. So x by x square plus 4 is constant. Just integrate y square by 2. And if I have to integrate with respect to x first, then so substitute x as minus u, dx is minus du, x is minus 1, then u is 1 because x is minus u, and if x is 1, then u is minus 1. And so we have the minus 1 to 1. Instead of minus 1 to 1, we have 1 to 1, integration 0 to 1, and then substitute x as minus u. We have this minus 1 to 1. If we interchange the limits, then give the negative sign. 1 to minus 1 replaced by minus 1 to 1, so write negative sign. And in the definite integration, the variable is if the variable, you can replace the variable, that is we replace u by x, then we have this. Because in definite integration, the variables are not important, that is you can replace any variable by another any variable. So I is, this is I and this is minus I, so 2I 0, so I 0. So we can solve this another by another method. So these are some exercise problems. Solve all these problems in your notebook, exercise notebook. So these are some solve problems of the same type. Integration 0 to 4, integration 0 to y, 0 to root y. This is on x integration now, and this is on y. So integrate with respect to x first. So if you integrating with respect to x, means y square is constant, x square by 2, upper limit, lower limit, and then its integration. Its answer is 32. These are very simple problems for 1 mark questions, objective questions. So here is 2x to 2 is the limit on y. So first integrate with respect to y. So x is constant now, x, y, and y square by 2. Integration of constant is constant into variable. Lower limit, upper limit value, then subtraction, and then we have the answer minus 1. Similarly, evaluate integration 0 to 1, x square to x, 1 plus 2y dy dx. That is x square to x is the limit on y. So that's why we have to integrate first with respect to y, because limit of y is in terms of variable, because of the Pavini's theorem. If the limit of y is in terms of variable, then integrate with respect to y first. So integrating with respect to y first. So integration is very simple. One integration is y, and 2y integration y square by 2. 2 to get cancelled, that is y square. Value at the upper limit, value at the lower limit, and then integration with respect to x. And then value at the upper limit, minus value at the lower limit, we have the answer. Then here the notations are t and s instead of x and y. So with respect to first, this 0 to s square is limit on t. So integrate with respect to t. And this quantity is cos s cube is constant quantity. So its integration is cos s cube into t. Lower limit, upper limit. And then we have this, and now we have to integrate with respect to s. So substitute s cube as t. And therefore 3s square ds is dt. And then we have this answer. And 0 to 1. And then we have this answer, upper limit, lower limit. 0 to 1 e raised to v root e 1 plus e raised to v dw dv. That is the 0 to e raised to v is the limit on w. So integrate first with respect to w. So this quantity is constant, 1 plus root 1 plus e raised to v. So its integration is this quantity into w. Then upper limit, lower limit, and then substitute 1 plus e raised to v as a t, and then its integration derivative is e raised to v into dv is dt, and by using we have this answer, value at upper limit minus value at lower limit. Then double integration over r y by x raised to 5 plus 1 dA. R is this, that is x runs from 0 to 1, x runs from 0 to 1, y runs from 0 to x square. This y by x raised to 5 plus 1 dy dx, that is integrated with respect to y first. So 1 by x raised to 5 plus 1 is constant, and just write integration of y is y square by 2, value at upper limit minus value at lower limit, then integration with respect to x, therefore x raised to 5 plus 1, substitute x raised to 5 plus 1 as t, or the derivative of x raised to 5 plus 1 is 5x raised to 4, so adjust 5, and then use f dash x divided by fx rule, log fx, f dash x divided by fx log fx, 1 by 10 log x raised to 5 plus 1. then value at the upper limit minus value at the lower limit. We have this answer, log 2 divided by 10. Then evaluate double integration over r x cube dA, where r is this. Okay, so the given integration I, suppose this is I, then I is equal to integration x runs from 0 to e and y runs from 0 to log x cube dy dx. So first integrate with respect to y, because integration limit of y is in terms of variable. So x cube is constant now with respect to y. X cube y is its integration 0 to log x, upper limit, lower limit value. And then now integration of uh, x cube into log x dx by using part rule. By using part rule, that is first log x is first, integration of second x cube integration minus integration of second derivative of first. And then we have this answer. And then again x cube by 3 integration is x raised to 4 by 4, 4 into 460, and we have this answer. So next problem, evaluate over d of this. D is the region bounded by the parabola y is equal to 2x square and y is equal to 1 plus x square. So double integration over dx plus 2y dA, either write, draw the figure or directly write lower limit, upper limit. So y is equal to 2x square and y is equal to 1 plus x square. The point of intersections are these. Solve these two equations simultaneously. That is, substitute here y as 2x square. So 2x square is 1 plus x square, means x square is equal to 1, and therefore x is plus minus 1. If x is plus 1, then y is 2. And so 1, 2 is, and minus 1, 2. These are the 2 point of intersections. And therefore x runs from 1 to minus 1 or minus 1 to 1. And y runs from 1 plus x square to 2x square, or 2x square to 1 plus x square, 2x square to 1 plus x square. So without drawing figure, we can also write limit, lower limit and upper limit. Here the figures, this is y is equal to 1 plus x square. Its center is what? Its vertex is, this is the vertex, right? X at 0, then y is 1. 1, 0 is its vertex. And y is equal to 2x square is this parabola. Y is equal to x square. X square means is the parabola around y-axis. Around y-axis. Both parabolas are around y-axis. But y is equal to 1 plus x square is the vertex at 1, 0. So this is y is equal to 1 plus x square. And this is y is equal to 2x square. And then take strip parallel to y-axis in order to integrate with respect to y first. And the limit of y is what? The lower limit is 2x square, because y is 2x square. Lower end, one end of this strip touches to the line curve y is equal to 2x square. So from this, y is equal to 2x square is the lower limit, and the other end touches to the curve y is equal to 1 plus x square. So upper limit is 1 plus x square. And in order to cover this strip, cover this region, we have to move this strip from this point to this point, from this point to this point. That is, we have to move this strip from this point to this point. Minus 1 to 1 is the limit of the x. And so after solving this with respect to first y, then with respect to x, we have this answer, 32 by 15. So similar problem, next problem, evaluate double integration over d, and d is the enclosed by curves y is equal to x square and y is equal to 3x. So y is equal to x square means around x axis, y axis, y is equal to x square. X square means the parabola is around y axis. This is the parabola, y is equal to x square, and y is equal to 3x. Actually, the y is equal to 3x, right? Draw like this. Y is equal to 3x. Okay, y is equal to 3x, which makes an angle. Y is equal to x is the line divides this plane in two parts. So y is equal to 3x is slope is 3, though it's above the y is equal to x line. And these are the point of intersection. How we can find the point of intersection? Solve these two equations. So if we substitute y is equal to x square in this equation, we have x square is equal to 3x. And therefore, x square minus 3x is equal to 0. Take x as common. So x into x minus 3 is equal to 0, means x is 0 or x is 3. If x is 0, y is 0. So 0, 0 is the first point of intersection of these two curves. And if we substitute x is equal to 3, then y is 9. And so 3, 9 is the another point. And then in order to integrate, suppose with respect to y first, so this integration is, suppose I is equal to integration, so x into y dy dx, right? Dy dx. So first we have to integrate, suppose with respect to y. So take strip parallel to y axis, and the one end of the strip touches to the y is equal to x square. So y is equal to x square is the lower limit, and another end of the strip touches to the y is equal to 3x line. So y is equal to 3x is upper limit. And in order to cover this a region, we have to move this strip from this point to this point. This point. Okay, and this point is what? Is 3. X runs from 0 to 3. And so solve this integration with respect to y. First means x is constant, then with respect to x we have the answer 3 raised to 5 divided by 8. Okay, so we will discuss remaining problem in the next lecture.